So what do y'all got for me? What questions do you have? Yeah. Bools? So the thing with let me back up. So the C language from which C++ is derived didn't have this idea of a Boolean variable. In the language, and this is certainly true of C++ as well, is that 0 is considered false and anything else, literally anything else, is considered true. So I can say let's see. Oops. Oh, darn it. Did I just accidentally close that? Yeah, C is a little more forgiving of that. Let me just stick with integers then. All right. 0 is false. Anything else is true. So that compiles, that runs. 32 is not 0, so that's true. If I do this, that'll compile fine. Yeah, that compiles fine. If I run that, question is Bob 0? No, Bob is not 0, so that is true. What about this? That's true as well, because that's not 0. That is a string whose value is a single character, the 0 character, right? That's not 0. That's something else entirely. Same thing if I use single quotes. That is not 0. That is a character. And that character happens to be the 0 character, right? Only the number 0 is the only thing that is considered false in the language. Okay? So C++, that's all, obviously I'm doing C++, and that's all true, just as it is in C. But C++ does add an additional type, which is a formal Boolean type. And that only has only two legal values, true and false. And you don't put them in double quotes or anything like that. You just do something like my flag equals true. So let me change this to be my flag. So that's true. And of course it's complement. That's false. So that's the deal with that type. Does that answer your question? Okay. What else? What else you got for me? Yeah.
Opening and reading files.
Opening and reading files. Okay. Yeah, I'll spend a fair amount of time on that, I guess. Any other questions before I dive into that one? Well, I guess I should bring up this. Alright, so this one, no new questions there. By the way, I'm getting people asking questions on the in-class Q&A outside of class. I normally like to delete this after class to keep it free so it's easy for me to visually see when there's a new question. So if you have a question for me to put on Piazza, awesome, I love it, but try to restrict yourself to responding to this in-class Q&A for if you wanted to ask something anonymously while class is going on. All right. Okay. Files. Let me start. So the assumption is that you watched the video prior to the start of the week, which was on file streams. Let me try talking about it from a slightly different perspective. Let me call this input stuff. So I want to create an integer age. I want to create a string called word, and I guess I'll create another integer called height. And I'm going to, there are a couple ways I can do this. I can say cin age, cin word, cin height, or if I wanted to, I could just say cin age, word, height, or any other combination there. So again, this is just input from the keyboard, cin. And then I can go ahead and spit out what I found. Cout age equals, I'll print out the age. I'll print in a new line, and then I'll say that the word of the day equals word, and height equals, whoops, let me add an end line. Again, this is something that I've done all in one line. You could do it on several lines. You can combine it however you want. It's all very flexible. All right, so let me run this, make sure it works as advertised. Now let me pull this up a little. Alright, then I run it. I need to give it an age, 30, a word, silver, height, 65 inches, I guess. I hit enter, and all that comes up. Now I'm going to convert this. Instead of reading this information, instead of reading this information from the keyboard, I'm going to read it from the file. So let's look at the changes we make. First, I include fstream, which means that I'm going to be dealing with files. Fstream. Next, I have to open a file. So let me go ahead and say that the I is for input. We're going to read input file stream. It's a variable, just like age, word, and height are variables. I'm going to give this variable a name. I will call it my fancy file variable. And here, I'll just do that. And then I need to open that file, my fancy file variable dot open. And I'll go ahead and provide it a name of the file that I want to open. We will open How about data.text? And what I'll do down here is that let me actually create data.text. So I entered 30, 65. How did I enter that information actually? Let's see here. Oh, I entered them all in the same line. I can do that. 30, silver, 65. Alright, so I put that inside of a file called data.text. Alright, so I added line 2. I added line 8, 9. And then rather than reading from the keyboard, I'm going to read from my fancy file variable. So note, that's it. I'm done with the changes. Let me go ahead and compile and run that real quick just so we can see it. Got the same information. That time it got it from the file. So the first thing that you need to get your head wrapped around is all of the commands you use from reading from the keyboard, nothing changes. That's how it works with reading from files, exactly the same way. You use the chevrons, you shove them into variables. Note that I didn't change anything other than in lines 13 through 15, that's where the actual input occurs. All I changed is where it was reading the information from. Rather than reading from CN, it's reading from this variable I created, which happens to be an input file stream, which I created on line 8. I open it and associate it with a file, essentially, on line 9. And then, other than that, there are no changes. Okay. So I think that is one primary thing to keep in mind about files is how similar they are to regular input. The exact same thing is true for file output. So cout, all the things, the end lines, basically all this information. No, in fact, let's actually do it just for kicks. I'm going to create an OF stream, that's for file output, another fancy file variable. How about, let me make these names a bit better. My fancy file input variable. So let me change that. My fancy file input, 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 input. Alright, now I'm creating, let me create this one here. I guess I'll put a little space, make it more readable. And then I'll call this fancy output variable. I'll open that. Fancy and we will write this to my output file. I'll put the .text. Really, the .text isn't necessary. If you recall, the operating system could care less about file extensions, so we could just as easily call that the my output file.bobby. But because everyone's accustomed to that, I'll stick with that. Now, rather than spitting to cout, what change do I have to make to line 22 to write out to the file instead of to the screen? Fancy output variable. There, I'm done. That's it. Output to the screen is exactly the same as output to a file. Let's give it a try. Compile it, run it. Now this time there's no output to be seen because I'm not spitting anything to cout. Right? But if I do an ls, we can see that it created my output file, and if I bring that up in my editor to take a look at it, there it is. A couple other things to note. It's considered good practice to close a file when you're done with it. In some cases you can introduce bugs. I don't think at the 111 level you're really going to encounter any of those bugs, but it's good to kind of keep it in the back of your head. When you're done, using a file, either for input or for output. Whenever you're done with it, you should formally close it. So basically, after line 19, I am done with my fancy file input variable, so I should close that. And the syntax for that is my fancy file input variable dot close. And then when I'm done, likewise, when I'm done using this output variable, fancy output variable dot close, close it. Okay. It's worth actually for another tip looking at lines 12, 9, and 12, another pearl of wisdom I can pass on to you based on the lab. And let me show you a mistake that several people make every semester. All right, so here's the task. Use CN to ask the user the name of the file. So you'd say cout, what is the name of the file? I'd actually have to see what the actual yeah, okay, you do ask that. What is the name of the file? And then you use a CN statement. You read that into a string variable. In this case, person types movieinfo.text. And then what you do is you open, and here's the key one where people get screwed up. Open the file the user named. So this is the way people start writing this lab. Vim lab stuff. They remember to do this, that's good. They say cout, and then I'll just copy and paste this line right here. And a little new line. They need to create a string, so they say string the file name, whatever you call it, and then you say cn the file name. Now it's time to create a file variable to read in the information. So the first step is to say, let me come back to this, recall. Okay, this is how we create, on line 8 is how we create an input file stream. So I will do that. if stream, and then maybe the person decides to be really literal about copying my notes. And then they need to open that up. Open. When they look at this and go, aha, movieinfo.text. All right, etc. to read in the file. What is the big error on line 12? Yeah?
It's useless to ask for the name of the file if you already just put the file.
Exactly. On line 10, you're asking the person, what file do you want me to open? And then on line 12, you tell them, go to hell, I'm opening movieinfo.text. Right? And I take stuff like that personally, actually. It makes me an angry human. Okay. So what you need to do, not this, is you need to be putting the file name. That's what you need to do. Yeah? All right. So where it comes, and what happens is when you compile it and run it yourself, it works fine. But when you submit the lab to that turn-in tool, you see the turn-in tool has its own file names that it provides, and then your code fails because movieinfo.text doesn't exist in that lab turn-in tool, right? So as long as you're sure to open up what the user types in, you'll be in good shape. All right, there's that. Let's talk just a little bit about types. And you'll have noticed that these include statements and these types are hung up on the word stream as in a river or a babbling brook or something like that. And the reason for that analogy is that it's actually quite apt to think of input in terms of a big, long stream of data just either being written out somewhere or being read in from somewhere. Let me see if I can get you to visualize that differently. When you open up, let's see, then input, what do I want to open up? I went with kind of an odd example. It's fine. I can change this. This will actually still work just fine. All right, so I put this on 3 separate lines. If you open this in a text editor, we as humans visualize that as 3 discrete separate lines that the program is processing. But in fact, as far as the program is concerned, that's just a single stream of characters, and I can use a tool called OD-A. Okay, this is really how if you want to understand how the programming language is handling input and output, it's better to think of your data in visualize it as a stream rather than as discrete lines. And you can see that here. This is just showing how far into the file you are, that you can ignore that stuff. But you can see there's a 3, a 0, then there's a new line, then there's a bunch of letters, then there's a new line, then there's some more digits, and then there's a new line. And as far as the underlying language is concerned, they're all just characters. The character 3, the character 0, the character new line, and it doesn't necessarily see them as separate lines. So let me see if I can write some more code and drive that idea home. I'll continue working with that data.text. So let me call it input stream fun. Actually, let me start with my input stuff. All right. Let's talk about how this is read in. So what I'm going to do is let me bring this in an editor. All right, so that's what our stream of characters looks like. On line 17, we read an age, and what kind of variable is age? Age is an integer, as we created on line 14. And the way the chevrons work is, 1, it ignores any leading white space, and as soon as it finds a non-white space digit, then it starts going, okay, I have an integer, I'm going to read in that integer, and the moment it sees white space again, it stops reading. So white space, it comes from a sheet of paper where there are characters that you don't visually see. It's just part of the white space of the page, and that's generally a tab, a space, and a new line, where a new line is something you'd create with your enter character or enter key on the keyboard. So line 17, I said it starts by ignoring any leading white space it finds. Note that it's ready to read in. Basically, the pointer to read in is right here, just before the 3. There is no leading white space to ignore, so it reads in the 3, it reads in the 0, and now it sees that the next character is a new line, so it stops reading right there. So when you finish, when you're done with line 17, that is where you are in this stream of stuff to be read in. There's actually a new line sitting there waiting to be read in that has not been read in. Then we go to line 18. Word is a string as declared on line 15. So the read on line 18 is going to ignore any leading white space. So the new line constitutes white space. It just ignores that. Now it sees a character. So all this starts getting shoved into the variable word until it once again hits white space and it stops reading. And that new line is still waiting to be read. And then the exact same thing with line 19 where it reads in another integer. It ignores that new line. It reads in the 6, the 5, and it stops right there. So this is an interesting thing that you may not have realized, which is there's still stuff waiting to be read in when you stop reading in. And that's okay. There's nothing that says you have to read in everything that's given to you. But that last new line is actually sitting to be waiting to be read in, and you never do read it in. All right. So let me go ahead and show you that the white space doesn't matter. So this is my output file, or excuse me, my, what are we looking at? Data.txt. All right. So that's what this is. This should read in just fine. I think, how do I want to do this? I don't want to keep writing out to this file. I'm going to comment that out. I will no, excuse me, that's fine. It was this one. I'm going to comment that out, and I'm going to change this back to cout, so we just spit it out to the screen. So, oops, the fancy output variable stuff is what I want to comment out. All right. So I'm still reading in from data.txt, but I just want to spit to the screen, so I don't have to keep opening that file to see what the output was. So let me go ahead and compile that, run it. All right, no surprises, but let me just drive it home. Let me put a bunch of spaces, a couple tabs in here. Let me put this on the same line and do that. We'll leave that on a different line. Let's run it again. Exactly the same, right? Because you have to visualize it as a stream. If I do that, let me have that go to the screen. So it's, and now let me bring this code back up. Whoops. All right, so again, our actual reading is occurring on lines 17, 18, and 19. It simply, up here, ignores any leading white space. All that's ignored. Oh, the asterisk means there's a whole bunch of spaces. But, let me make not so many spaces so that my OD program doesn't OD. So let me do that many. It'll run exactly the same. All right. So line 17 ignores any leading white space. It sees the 3, the 0. That gets thrown into age. It hits white space. It stops reading right here. And then line 18, reading in Word, ignores all this white space until it sees the S in silver, reads that in, stops at this new line, and then height reads in the new line, or ignores the new line, reads in the 6, 5, and ignores that new line. If I were to come here and add a whole bunch more white space after the 65, let me do that octal dump. Let me run it again. Okay, the output, it's still reading in everything the same. We get the 30, the silver, and the 65, but note that it is right here. That's where I stop reading in, and my program is actually ending without any of this stuff being read in. Okay.
So is that where the close comes into play? So you don't, that doesn't go.
Yeah, I did hem and haw a little bit about trouble you would or actually wouldn't get by not putting close. The reason it, in our case, isn't an issue is that if you do not close it yourself, when the program ends, it'll close it for you. Where it becomes an issue, and we don't really do this in 111, is this variable that we create and open, after we close it, we can reopen it again on a different file, right? And so that's where it becomes a problem, is if you're using the same variable to open and close several files, or the same file repeatedly. We're not doing that, so it ends up being nothing other than a good habit to get into, for this class anyway. The last thing I guess I want to talk about in that regard is getLine. And getLine, oh, let me see. Should I just create another example? I got a lot of files here. Yeah, let me call this getLine stuff. And I'm going to actually borrow, oh, let's see, I ended up not using that one. Alright, let me borrow some of this code. I'll take lines 8 and 9. I will yank those. Come back to this file. I'll paste them right in there. String. My happy string. Part of my so the variable. Let me talk a bit about the variable names. There are two things about the variable names I'm just trying to get across. One is that so many people just use single letters for variable names. I'm trying to show you or encourage you not to do that. The second is, if people are a little bit hazy as to the syntax of the language and what's legal or not legal, if I put X or I put var or something generic, people can go away with the impression that the language requires this variable to be called var. And so I'm choosing names like this to drive it really home that there's no way in hell that the language designers would force programmers to use these variable names, right? So it's just my way of getting across the choice is yours. So, getLine. getLine takes two arguments. If you're reading from the keyboard, the first one can be cin, and the second one is a string that you want to read into. Now, first, what you have to realize is that getLine only works with strings. A lot of times I'll get folks who create an integer and then they're going to try and read an integer in using getLine. No, getLine exclusively works with strings. The second is how much is read in with getLine. The first thing is this idea of ignoring white space doesn't apply for getLine. getLine reads in everything. So it will read in absolutely everything, and it will stick it into the string variable up until the moment it finds a new line. So if I was to run this on data.text, my happy string would contain all these spaces. It would contain this 3, this 0. It would contain all these spaces. It would contain silver. Now it hits a new line. It actually gobbles up and throws away that new line, and it stops reading here. So basically, 6 is the next character to be read in. So let me go ahead and just run that really quick to emphasize that that's what happens. And then I'll just spit it out to see out. I'll say my happy string equals. And so, this is actually a nice thing to do is if you're unsure of what is or isn't in a variable, what you do is you put like little arrows or some sort of bookend to either side of the variable that you're printing out. Now, anything between these little arrows I created is exactly what is inside my happy string. So let me do that, and let's try running that. Alright, so what am I forgot a semicolon somewhere. Yep, right there. Let's try again. Okay, now what am I doing? So it's saying sometimes if you get this implicit instantiation and you're dealing with files, then that invariably means that you forgot to include fstring. All right, here we go. Let's look at it. And there it is. So there's the leading spaces, the 30 more spaces, silver. It saw the new line, and that's where it stopped reading. It doesn't have to be. That's the default behavior of this getLine function. And now you can see why it has to be a string, because things like spaces and letters, like silver and things like that, obviously don't apply to integers. So that's why you would never have an integer as my happy string. This has to be a string type variable. But an interesting thing is that this thing stops reading in characters at the new line is what I'd call default behavior. You can change that to whatever you want. So let's say I want to stop at the letter V. And instead of gobbling up and throwing out the new line and stopping, it will gobble up the letter V and throw it away, and that's where it will stop. So it should stop at the L in silver. And so that's this third argument here that you're not required to provide. If you do, it'll stop there instead of a new line. Let's give it a try. And there you go. So getLine will stop wherever you tell it to stop. In fact, that includes, don't get hung up on new line. It is not special. It's just another character. How about if I stop at the 5 and gobble up the 5? Then it should read in the new line and make that part of my happy string. So I'll stop at the 5 in 65. Let's try that. So you'll notice that after the silver, that new line is part of the string. And then here's the 6, and then now that's the end of my happy string. All right, so a string can hold any character at all, including new line characters or tabs or spaces or whatever.
Can you put in multiple things instead of like the 5? Can you put in 65 so it'll stop?
No, you have to give it a single character to stop at. Yeah. And then the final thing, which is a technique you can use, is what if you do read in a string, but you know it's going to be an integer? So, let's see. I guess I should go string to int.cpp. I'm going to create a different file here. Let's say data2.txt. So let me come up here, data2.txt, and 33. Right, that's it. I'm just going to put a number in there. So I can create a string. I'll just call it str this time. Or how about age? And now I'll call it my age string. And then I use getLine, and I'm going to read from that variable. I'm going to read it into age string. Let me spit it out. So, this is another thing is, before I continue, I'm going to compile and run this. When you all are developing your programs, a big mistake that you do when you're starting out is you bust out about 100 lines of code, and then you get out of your editor, try compiling, and you got 100 things going wrong, and it makes it tremendously difficult to get to the bottom of it. The best way to develop, and this isn't for 111 students, this is for any professional, is you write a very small amount of code, then you get out, make sure it works, and then you go back in, write a little more code, go back out, make sure it works, so that if something goes wrong, it has to be in that little bit of code you added. If you write, and the best example is this loops thing that you all did, that in class assignment, write a loop, compile it, run it, add another loop, compile it, run it. What some of you are doing is writing 9 loops. And then you get out, and now it's pandemonium, right? So do things in as small steps as possible. So what I'm doing to practice what I preach, I'm going to make sure that I can read in this string and print it out. And that's fine. But a mistake is then, okay, well, what if I want to treat it? I read it in as a string, which is fine if you do that. But I want to do some sort of numeric manipulation on it. So let me try saying integer new age, or how about decade after, is equal to age string plus 10. And then maybe I'll spit that out. And I get all sorts of errors. And it is basically invalid operands to binary expression. The binary expression is this on the left and this on the right. The language doesn't have any idea of what you're talking about, trying to add 10 to an arbitrary set of characters, right? So as far as the compiler is concerned, age string doesn't contain 33, and it gracefully converts it to a number and adds 10 to it. There could be anything. There could be Todd in that string, and Todd plus 10 doesn't make any sense at all. So all is not lost. All you have to do is there's a function called s2i, which means convert a string to an integer. And once I convert it to an integer, I can add something to it. And there we go. Okay, so that's a nice function to be aware of, converting strings to numbers and to integers. All right, so that's all I got for you. We will see you in lab momentarily and tomorrow.
So I wonder if the string is actually a string, like Todd.
Then S2I will fail. And actually, I think it just fails silently. So we can look it up real quick.
What, a terminal on your phone?
If it'll ever do it.
Yeah, I'm Steven.